Alright, we're going to have a note-taking session today and discussion tomorrow over whys of the gas laws. Specifically tonight we're going to talk about energy. Now, here is a lot of the equations we've had. It's not all of them. Take a chance if you need to get them updated. Tomorrow I want you to be ready to have a discussion about the why of the gas law. The kinetic theory of gases, these 4 points right here, and let's talk about these and why these 4 points are the way they are. So be ready to discuss those. Take a chance, pause it, write down yourself some notes, some things, some jottings that you want to be able to talk about tomorrow. 2, maybe you got 3, maybe you got all 4 things, 4 thoughts. Specifically here though today we're going to be talking about the amount of kinetic energy that is available in the molecules. And when we're talking about their kinetic energy, it's 2 things should come to mind at this point. A, you should be thinking about the kinetic energy, meaning the movement of those molecules, and each molecule has a certain amount of mass, so there is a certain amount of kinetic energy there because the masses are moving, and because they're moving there's a certain amount of energy that can be they're vibrating back and forth, so there's a certain amount of thermal energy which can result in heat or temperature. So that's the things I'm hoping you're starting to realize when you hear that kinetic energy now. It's not just about big things that are moving. It can also mean gas molecules. Our first example says at what temperature is the average kinetic energy of the molecules of oxygen equal to 6.8 times 10 to the negative 22nd joules. What is the temperature of hydrogen molecules with the same average kinetic energy? Well, let's decipher this problem here a little bit. They're telling us the energy, so we can put this in right there, and K then is the only other variable, and that's the Boltzmann constant. So that was from a couple days ago. Let's see if we can't find that. And there, I found it. No, it's not something I remember off the top of my head, so I'm sorry to disappoint those of you. I know you look at me as a superhero, but even us superheroes have our limitations. So let's take a look at this. 3 halves, which is 1.5, but we'll put it right in here as they say. 3 halves times the Boltzmann constant, which is 1.38 times 10 to the negative 23rd. Essentially is going to times the temperature is going to give us the energy, which is 6.8 times 10 to the negative 22nd. And when you go about finding this out, you're going to get the temperature is equal to 32.9 Kelvin. So not a lot of energy there, not a very warm temperature. Let's have you go ahead and work out the second one. And when you multiply this out, you're going to get an answer of 4. Well, doohickey here doesn't want to work. 4.14. Now let's try this again. Still here. There we go. 4.14 times 10 to the negative 21st joules worth of energy. Now, the one thing we did not address is up here. What is the temperature of hydrogen molecules with the same average kinetic energy? I want you to take a few minutes to jot down your thoughts and answer to that, and be ready to discuss that as well. Other than that, ladies and gentlemen, that's it for our ideal gas laws notes tonight. And once again, I'll see you on the flip side.